Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the challenge number 141 called the linked list cycle. And for this particular challenge, it says given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that the pos of the position is not a pass as a parameter, and return true if there is a cycle in the linked list, otherwise return false. And we have the example 1 right here of the linked list. We have the head node of the tree, head of the linked list node, and connected to the 2, since it is one way, denoted by the single arrow that pointed to the next node, which is 2, and it points to the next property of 0, because on the definition of the single linked list, which has a custom class of the list node called the list node, and the value, which is the number of the 2, 0, and -4 or -4, and we have the both property of value and the next. And for the next property is pointing to the next node of the linked list, and we are tasked to find if the current linked list of the head parameter here is considered in a cycle or not, in an endless cycle or not. So that is the next property, and we have the value of 0, and we have the next property points to the next node, which is -4, and the -4 points to the previous node of 2. And so the example 1 here is considered a cycle 3 to 0 -4, and then go back to 2 0 -4, and endlessly loop within it. And we have the input of the head, which is this is represented by the array, but for the real case is about a linked list connection between one and another. We have the position of 1, and the output is equals to true is because this one represents as a cycle. And the explanation, there is a cycle in the linked list where the tail connects to the first node, which is the 0 index on the position 1 right here. Since it is 0 index, then 3 is considered index 0, and this one, index 1, is positioned on the index 1, which points to the after the last node of the -4, which points back to the index 1, so that is completes the cycle of the linked list node. And we have the example 2 right here, which is on the 2 nodes. 1 points to 2 and then points to the node of the 2 points back to the node 1. So this is also a cycle, then the output is true. And for the last example of the example 3 right here, which is a singular node 1, and the output is false because there is no cycle within it, there is no another node, and there is no cycle in the linked list. And let's solve this out, but before that, we are using a TypeScript as our language. If you want to use something else other than TypeScript or JavaScript, then go ahead. I encourage you to do so. And we have the value of the data type of the list node custom class called the list node, which takes 2 parameters. The first one, which is the value consisting of the data, and the next property, which points to the next node of the neighboring node. And we can construct this with the property of value, and the next, it is possible to be undefined, but it is not a concern for now. And we have the function of the head cycle, which has only one parameter called the head in the form of either list node or null, and the expected output is in the form of boolean. So whether we return true or false, it's up to the challenge that we need to solve. Okay, so for the first one, we need to use a return false as the placeholder, or just as the formality, in order to fulfill the function requirement of the hash cycle function, which is expected output is in a form of boolean because we are using the TypeScript. And for the first one, we need to declare a pointer to points out to traverse over the node one by one and check if it is in a cycle or not. And I'm going to declare this as the let of the current node, which takes the head parameter as the variable of the current. So that way we are declaring a variable of the current just like the head, which in a form of list node inherited from the head. And if I happen to run this using the Escalibur drawing to visualize this, we have the head, which points to the 3, 2, 0, and 4, which points to the node 3, 2, 0, and then finally -4. Don't forget the comma. And this is the sequence of the node using the arrow sign, -4, and finally points to the back to the node 2, which is right here. And then so on and so forth endlessly, because it is in a cycle. And for the, we are declaring another let current, which is the same as the head. So for the current node right here, I declare is for traversing over the head node. So the head parameter will not move, and the only thing that moves is only the current pointer. So if we happen to draw an arrow sign which has the name of current, or just the C, oops, let me make this larger, and we have the current node, current with the smaller font, which points to the current head of the node, since the head is 3 right here. Then the current will move one by one using the iteration, whether it's while loop or for loop. But for this case of the node operation, we always use while loop for this case of the challenge. And the current move will move one by one to points the head node, which is 2, which is 0, 4, and then 2 again, and then go back. Since 2 is points right here, then it's going back to the -4, and then go back to 2 again, and it is endlessly loop. And if we happen to represent this in an array, just like the not the hackering, but the LeetCode says, let me use the current is going to be equals to the 3, oops, I'm going to use array instead, 3 to 0, -4, and then 2 again, and so on and so forth. Let's say if we happen on the current state of the points to the current head without any while loop, then the current will represented as this data sequence. But if we move the current by 1 using the assigning the current with the current.next, then we will move this by 1, which points to the next property, because on the list node class we have the property of both value and the next property, so the list node will be represented as the blue color. We have the value property and the next property, the value itself, which is node 3, node 2, 0, -4, and then node 2 again, and the next property is points to the denoted by the arrow sign right here. And if it's points, the current points to the node 2 right here, then the current will be like this. This is the current head, and the head stays at the 3 to 0, -4, 2, and endlessly. So that is the sequence. And then the next one, which is 0, then the current will be 0, -4, 2, 0, and then -4 again, and then so on and so forth, because it is looping in the same place. And if we point the current to the -4, then the current head will be points to the -4, and the next node should be 2, 0, -4, 2, and then 0 again, -4, 2, and then 0, and then -4, and so on and so forth. So using the while loop of the current equals current.next will make the current variable right here. So that is why I'm using the let variable declaration of the syntax using the current, and then the current will points to the assign with the current.next property, because the list node has the property of value and the next, since next is pointing to the 2 right here. And if we happen to on the state of the -4 as the current head, then the current.next, you guess it points to the node 2. Let me take a screenshot of this picture and copy this part. I'm using a Linux. and then go back to our escalator and we can paste this right away. And the current equals the current.next. We are assigning the current.next property assigned to the previous current, which points to the node 2. Let me make this one going to the above the picture right here, but for this one we need to send this backwards, send to back, and the current will be visible, and the current arrow will be pointing to the node 2 right here. And then the while loop will run again, and then current equals to the current.next 0 -4 and go back to the 2 0 -4 again. So it will loop endlessly. And if we happen to run this using the while loop, while the current is not equals to the null, as long as current is not null, which points to the not null to denote that it is not the end of the array, not the array but the list node yet, the end of the list node sequence, then it will run, the while loop will run as long as it is not the end of the sequence of the list node. And for the example 3 right here, since the 1 will point to the next, which is the node of null, then the while loop will stop and we return false right away, just like on the output right here. So it will be catched by the return false statement because while loop will not run again, and because the node 1 is already points to the next node, which is node null, and the node 1 is the only node that is not a null. Then we move the current by 1. Current equals to the current.next property. And if we happen to run this with a node from this example 1 and example 2, what we will get is an unending sequence. And the other way to describe it, it will be looped endlessly. So let's run the code to see what I mean. And the test result will run endlessly, and we have the time limit exceeded error. Is because the while loop run endlessly from the example 1 right here. We have iterating the 3 to 0 -4 and then go back to 2 0 -4, go back to the 2, and then while loop will thrive forever. The same thing also happened to the example 2 right here. So to prevent this, by using the while loop check to check if the current is not null, to get around this, to find the main objective of our challenge in order to get the if it is a cycle or not, then we can use a technique called the turtle and a rabbit. A turtle and a rabbit is basically a turtle will move one at a time, and the rabbit will move 2 nodes at a time in the turtle and rabbit technique. And that way this part of the current of the equals to the current.next is considered a turtle. But how do we declare the rabbit one? It is fairly easy, using the let of the current 2, and then we can declare this as the head, the current head. From the first current, we can rename this as the turtle or just a current as it is, but it is up to you. And for the sake of the challenge, I'm going to use current 2 represented current 2 as the rabbit and the current 1 as the turtle one. And then we can use the current 2, assign this as the current.next and then .next again. How does this works? Let me go back to our code. Let's say we have the pointer of the current right here, which stated as the turtle. We can use color, orange color. Then let's copy this and declare another one called the rabbit. And let's change this to red color. And we are basically on the same point of the first initialization of the current of the current head. Current, it points to the head, and then current 2, it also points to the head, the same start. And since we are already on the same starting point, then the rabbit will move 2 at a time using the current.next and then .next again, accessing the next property, because the next is accessible of the next property is in a form of another list node. So the list node can be accessed with the another next property as long as it is not a null node. as long as the current is not null. So the rabbit will move 2 at a time and the turtle will move 1 at a time. So the first iteration, this is going to be like this. The rabbit is positioned on the node 0 and the turtle is positioned on the node 2. And the rabbit will move 2 at a time, going to -4 and then go back to the node 2. And the turtle, will move to the node 0 because it moves 1 at a time. And then this is the iteration number 2. What about the iteration number 3? The same thing, goes by 1 and the rabbit will moves by 2, 1 and then 2. Then they are both meeting they both meet at the same node state, and we return this as a true because this is a cycle. So that is the one way to detect if the list node is a cycle or not. And let's go back to our code, and we can use the turtle and rabbit technique, and we move the current 1 at a time, and we move the current 2 times in a row. So for the next one, we need to add an if check. We need to add an if check to check if the current of the turtle is on the same position as the current 2. If the current is equals to the current 2 as the same head, then of course we have to return true. If it is not, then the while loop will stop. If it is not a cycle, the while loop will eventually stop, and we can just return false right away. But for another check, don't forget to change the current of the null right here, as the current 2 is not equals to null, is in the strictly not equals to null. And also check for the next node of the current 2 of the one that iterates this is the rabbit one, and the current 2 of the next property is also not null. And that way we are checking if the current 2 of the rabbit is currently not null, and also if it is a null, then of course it's not considered a cycle because rabbit moves 2 times in a row, and the turtle one will move 1 time in a row. So for the current 2, we have to check if the current 2 is not null, and also the current 2 dot next, the next node that it will be traversed through is also not null if the future node or the node forward before the rabbit pass through is also null, is already null. Then of course the while loop will stop and we can just return false because it is not considered a cycle. Then it is just a one-way trip instead of a looping trip. So let's run our code to see if it works. And we still have the time limit exceeded. It's because I had one mistake right here. Of the current 2.next, we are iterating instead of the current 2 pointer, we are pointing of the current, which is the turtle itself. Instead, we can change this to the current 2.next and then .next again. So that way we are properly traversing the rabbit to the next node 2 times in a row instead of moving the turtle. So let's run the code again to see if it works. So this is why that we have to be meticulous about what we are trying to solve, specifically about the coding challenge. So let's submit our code to see if it really works. And we have the runtime of 45 milliseconds, which is kind of nice between the graph right here. And so that's about it. I hope you understand my explanation, and if you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.